Hello. Today we'll see basics in determination of type of organic compounds. There are four types of organic compounds: acid, phenol, base, and neutral. So what is the theory behind separation of these compounds and to find the type of these compounds? This comes under practicals of organic chemistry. Acid has general formula RCOOH. This group is carboxyl group. Phenol is a ring, aromatic ring to which OH is attached. This ring may be other than benzene, so we can generalize the structure as ROH. Bases are either aromatic amines or aliphatic amines. They are further classified into primary, secondary, and tertiary amines. For the time being, I will write here a base as RRNH. R2NH is a secondary amine, RNH2 primary amine, R3N a tertiary amine. All these are bases. This R may be alkyl or this R may be aryl. And neutral. Neutral means there is no acid, there is no phenol, there is no base, so the remaining compound, whatever it is a neutral, which is not reacting with common reagents like sodium bicarbonate or potassium bicarbonate or carbonates, alkali like sodium hydroxide or KOH, this HCl. If the compound is not reacting with any acid or any base or any carbonate, is a neutral compound. Now we are going to concentrate on the theory of how they are separated, what happens when these reagents are added. For example, now when we check acid, carboxyl acid, we add in it sodium bicarbonate. When acid reacts with sodium bicarbonate, it gives RCOONA, that is sodium salt of carboxylic acid, H2O, and carbon dioxide. This gas is given out. As this gas is given out, we see effervescence or bubbles. It is indication that carboxyl group is present or acid is present. As this is a salt of sixth group of inorganic analysis, these have property to get dissolved in water. So to reprecipitate it into this, any acid is added it becomes RCOH. And the very common acid added is HCl. So it forms RCOH plus NaCl. Why this acid is reacting with sodium bicarbonate, but phenol requires sodium hydroxide? It is because sodium hydroxide is a weaker base than carboxylic acid. So phenol does not react with sodium bicarbonate, and the advantage is taken to separate acid and phenol by their reactivities. Phenol is also acidic, but it requires with a stronger base. For example, phenol plus NaOH gives sodium phenoxide plus water. This is again a salt of sixth group of inorganic analysis. They have property to dissolve in water. To regenerate it again into this acid is added, it gets converted back or reprecipitates into phenol. As this is weaker acid, it does not react with weaker base. As this is weaker acid, it reacts with weaker base as well as a stronger base. So for separation of acid, we can use this or this, but for separation of phenol or detection of type of phenol, we can use NaOH only. Base contains nitrogen. Nitrogen has a lone pair. Lone pair reacts or it is given to any Lewis acid or mineral acid. So advantage of this is taken, which is totally different from these two. When I'm writing a primary amine, when primary amine reacts with HCl, the lone pair is given to H, and the bond between H and Cl is broken. It gives R NH3 plus Cl minus. This is ammonium salt. Ammonium salt is again a salt of sixth group in inorganic analysis. So it also gets dissolved in water and reprecipitates by adding opposite reagent like alkali. HCl gets neutralized and amine is regenerated. Same thing happens for secondary amine, tertiary amine. So the basic theory of detection of type of organic compounds is choose a reagent in which one of the type of that compound is reacting and dissolving, and to it add the exactly opposite reagent by which it reprecipitates. So we can filter it, we can reprecipitate it, and we can get it. This is for our first practical batch. This is for insoluble compounds. For soluble compound, the tests are very simple. A solution in water is prepared. Red litmus, if it remains red, then it may be acid or phenol. Phenol is confirmed by ferric chloride test, which gives violet color, Acid is confirmed by sodium bicarbonate, which gives effervescence. And base is confirmed by converting red to blue litmus. Here in acid and phenol, blue also gets converted into red. These are the two tests for acid and phenol, and this is the test for base. But this is not a very good test which is given by bases, as they are not very strong bases. This is alright. Okay.